Every single day, we move through buildings and spaces that are governed by a set of invisible rules. And these aren't just suggestions. They're incredibly detailed codes designed for one reason, to keep us safe. Today, we're going to pull back the curtain on a really important one, the SANS 10400D standard for public safety. Let's see how it all works.
So think about it. What is it that actually turns a potentially hazardous spot, like a high balcony, a steep driveway, or even a backyard swimming pool, into a space that's safe for you and me to use? Well, the answer is in a set of very specific, legally recognized requirements.
So here's our roadmap. First, we'll get a handle on how the code itself is written. Then, we'll dive into the rules that are all about preventing falls. After that, we'll look at ramps and driveways. And we'll finish up with the absolutely critical safety layers required around swimming pools. All right, before we get into the nitty-gritty of all the measurements and materials, we first need to understand the language of the code itself. It's actually written in a pretty clever two-part system. First up, you've got what's called a functional regulation. The easiest way to think about this is as the big idea, or the why. It just states the overall goal in really simple terms. So, for instance, a regulation might just say that the edge of a balcony has to be designed to, quote, prevent any person from falling. See? It doesn't say how high or what to use, it just gives us the fundamental goal. Okay, so if that's the goal, how do you actually achieve it? Well, that's where the deemed to satisfy requirements come in. These are the specifics, the practical, step-by-step instructions, the how. If a builder follows these exact measurements, they are automatically considered to have met the big idea from the functional regulation. It's basically the playbook that tells them exactly what to do. Okay, so let's see how this two-part structure actually works in a real-world situation, like guarding against falls. This is where those deemed to satisfy specifics become so important. So just imagine for a second you're standing on a balcony, maybe a bridge, or even a flat roof. There's a drop right in front of you. At what point does that drop trigger the need for a barrier? And just how high does that barrier have to be? And this is where the code is brilliantly clear. The rule is simple. If any edge you can walk up to is more than 1 meter above the ground next to it, it must have a protective barrier that is at least 1 meter tall. A 1 meter drop means a 1 meter barrier. It's that straightforward. But, just having a 1 meter high barrier is only half the battle, right? I mean, what about the gaps between the railings? It wouldn't be very safe if a small child could just slip right through. The code has a very specific rule for this too. This one's often called the 100-millimeter sphere rule. And what it means is that in most buildings, any gap in a barrier, whether it's vertical or horizontal, cannot be big enough for a 100-millimeter ball to get through. Now, to give you an idea, that's about the size of an average coffee mug or a clenched fist. It's a super important detail, and it's there specifically to protect young children. Okay, let's switch gears. We've talked about heights, now let's talk about slopes. How does the code make sure that ramps and driveways are safe, especially right where they meet a public street? This diagram shows us exactly how it's done. What we're looking at here is a side view of a car ramp that connects a building to the street, and the key thing to notice is that the slope, or the gradient, it isn't the same all the way down. The code actually calls for 2 different angles, and for a really good reason. So here's the crucial part. For the first 5 meters of that ramp, the part closest to the street, the slope can't be any steeper than 1 in 25. That is a very gentle slope. But once you're further away from the street, a much steeper gradient of up to 1 in 8 is perfectly fine. So why the difference? Well, that gentle slope right at the exit gives drivers much better visibility of pedestrians on the sidewalk. It also stops cars from shooting out too quickly into a public area. It's all about that transition. And that brings us to our final section. And honestly, this one might be the most critical of all. How these regulations create layers and layers of safety around swimming pools. The big idea for pools, the functional regulation, is very direct. It says the owner has to make sure access is controlled. But what does controlled access actually mean in the real world? Let's break down those deemed to satisfy rules. The code gives you 2 main ways to do this. As you see on the left, you can put a compliant fence right around the pool itself, creating its own little secure zone. The other option on the right is to use the main wall around your property as the barrier. Whichever way you go, the goal is exactly the same: create an unbroken barrier that completely stops uncontrolled access to the water. Now, the gate is probably the most important part of this whole system, and the rules here are absolute non-negotiables. The fence and gate have to be at least 1.2 meters high, and again, no gaps bigger than 100 millimeters. But here's the key part. The gate must be self-closing and self-latching. That means it can't be left open by accident. It also can't open inward toward the pool. And the whole thing has to be designed without any footholds that a kid could use to climb over. Every single one of these rules is another layer of safety. And this all leads to a really stark reminder, and this is a direct quote from the standard itself. Following all these rules is just the bare minimum. It does not protect you from legal responsibility if something bad happens. It really just highlights the incredible, real-world seriousness of these public safety standards.
So the next time you lean on a balcony or walk past a swimming pool or drive out of a garage, you'll know a little bit about the hidden language of safety that was designed to protect you. And it makes you wonder, right? After seeing these rules, what's one safety feature out there in your world that you're going to look at a little differently now? Thanks for watching.